Today we'll be continuing our study of geometric series. So first, just recall the sum formula. That's what we're going to need today. So this is sum formula for a geometric series. And let's do our first question. A union contract specifies that each worker will receive a 5% pay increase for each year for the next 30 years. 20,000 is your first year salary. What is a person's total lifetime salary? So lifetime means we're going to add each year, which is why we need to use this sum formula. So we're going to sum 30 years of work. The first year is 20,000. Multiply this by 1 minus, and a 5% increase, so right here, a 5% pay increase, the way you model that would be R is equal to 1.05. So just write that 1.05 to the 30th power and divide that by 1 minus R. And of course, sorry, R should be 1.05. Now plug in your calculator and you get, this is about $1,328,777. Okay, so pretty straightforward. Type in your calculator and we're done. Now we go to the next example. This is where it gets a little bit harder. It says finding the sum of an infinite, so I have that word infinite, geometric series. So this is weird. It says find the sum of this infinite series, and this thing continues forever. So the first thought should be, if it continues forever, how could I possibly add everything? So first, let's investigate. Notice how every single time you jump, the number is getting smaller. We can see the R value here is -1/2. R times -1/2. R times -1/2. R times -1/2. Every single time. So that's kind of interesting. So if we look at the sum formula I gave you earlier, we're going to notice something interesting happen when, let's assume this R right here, let's say R were like a half, meaning like a fraction. If we actually go to infinity, a1, 1 minus, imagine we actually did that. 1/2 to the infinity, well, 1 minus, and this is 1/2. Sorry, that infinity should be right there. This piece right here we learned in our limits chapter. 1/2 to the infinity power, that basically goes towards 0. So this thing actually doesn't even matter. So really, the formula boils down to this, a1 over 1 minus 1/2, assuming R is a fraction like that. So imagine it was just a generic variable like R. And notice how we get a nice formula right here. This is our infinite sum formula. But notice how we generated it. We only could create this given that R was a fraction like that. So a stipulation of this is that R has to be less than 1. But of course we're seeing, well, this is negative. So to fix that, you say, well, that would mean the absolute value of R must be less than 1. So another way to think of it is the series must converge. So the two pieces you really want to highlight are going to be right here. And if that's true, that means this, that the series will then converge. So to try this formula is actually pretty straightforward. Infinite sum, the first term is 3/8 over 1 minus R, which is -1/2. For this, we don't need to calculate it. We can just do this by hand. That's 3/8 over 3 over 2. So that's 3/8 times 2 over 3, and that's 1/4. Which is pretty cool, because that means if you add up everything to infinity, you get a quarter. Let's try this one. Express 0.7 repeating as a fraction. So this is kind of a cool question because all of you know what 0.7 repeating means. It means 0.7 forever. So now let's think of it as a series. What if I thought of this as 0.7 plus 0.07 plus 0.007 and so on? Then I can use my formula. The formula here would be 0.7 over 1 minus, and the ratio here is just 0.1 because multiply by 0.1 every time. So that's 0.7 over 0.9, which would be 7 over 9. And you can actually verify that because if you type that in your calculator, let's go back here, 7 over 9, you do get 7 repeating. Now here's the last example. For the following series, find the interval of convergence. So if you ever see this, what that means is you want to make the series converge. Meaning you want it to get smaller and smaller and smaller. So the first thing you want to do is figure out R. So what's happening every single time? And if I look at it, I can see, well, R is simply 3x because you're multiplying by 3x every single time. And to make it converge, we'll look right here. The absolute value of R must be less than 1. So if the absolute value of R must be less than 1, then the absolute value of 3x must be less than 1. And hopefully you remember how to solve the absolute value inequality like this. Just set it between -1 and 1 and solve it. So right here is what we call the interval of convergence. Meaning if x is between these values, that will make this series here converge. And then we could actually find the sum. So notice how the second part of the question says, find the sum in terms of x. So that's actually not too hard. We're just going to write s infinity. The first term is 1 over 1 minus the ratio, which is 3x. And right here, that's your sum in terms of x. And then here's the cool part. Find the value of x that makes a series converge to 5. So just get the thing you found, make it equal to 5, and solve it. So that would mean 1 is equal to 5 times 1 minus 3x. So 1 is equal to 5 minus 15x. So 15x is equal to 4. So x would be 4 over 15. So what this means is if x is 4 over 15, the series will converge to 5, meaning the infinite sum would be 5. And we're done.